Thank you for stopping by to check out this episode of Vintage Audio Review. In this episode, we're going to talk about this Pioneer A-9 integrated amplifier. This was Pioneer's top-of-the-line integrated amplifier in 1981 and 1982 and sold for $800, which, according to the inflation calculator, would be $2,400 today. It weighs in at approximately 35 pounds and was rated at 110 watts per channel into 8 ohms at 0.003% THD. We'll see how well it does today, 40 years later, in a bit. But it has some neat features, and I wanted to go over them with you, and so that's what we're going to do now. Okay, so let's start by turning the power button on. You can see that we got a bunch of nice little green indicators as to the different functions. You can see we're on speaker A here. Our balance control is centered. We're in stereo mode rather than mono, and we're using the tone controls right now rather than the straight line, which would be indicated up here. We also have LEDs to indicate if the loudness filter is on or the subsonic filter is on. We do have, if we go to phono, we do have either a moving magnet or a moving coil position, which is set inside here. We'll get behind that. We'll get inside that in a minute. We also have our tuner input, auxiliary input, tape 1 and tape 2 inputs, which are indicated over in that area. Down here we do have an LED for protection. If it comes on, the amplifier is in protection mode. And then we have the muting down here. I'll turn the muting switch on, which is right here. It says it's muting. And we do have a subsonic filter switch LED, which is also indicated down there. Here are our treble and bass controls. Now these are a little bit different in that we have turnover points for each of them. For the treble, we can set it to either a 2.5K or 5K crossover point. And for the bass control, we can set it for either a 400 Hertz or 200 Hertz turnover point. Now we have this little secret door, which goes down under like that, and go back to the treble and bass controls, and you can see that is set right here, whether you're on 2.5K or 5K or 200 Hertz or 400 Hertz, and then your actual amount of bass or treble is set here with that knob. We have our sources for the record out selector on the tape deck, and these are here, and as I move them you can see the different selection. That's phono 1, etc. Here's our balance control. Now when I move that one way or the other, look at what happens over to this. So if I'm a little bit right, oops, it tells me I'm off balance a little bit, or if I'm off the other way, the indicator, the LED changes to red if you're not directly balanced. This is our speaker switch. If I add B, it came on over here. Take A off. Here's our stereo mono button. It goes red if it's in mono. Now this is the straight line. This is why the unit was brought to me, is that it would only work if it was on the straight line mode. Now watch what happens here. If I go to straight line, it just shows a little indicator, a little arrow. It's going straight through. It's bypassing the tone controls. The amplifier still worked for him, but he really wanted to be able to use the tone controls, and so that's why I got it, to figure out why the tone controls didn't work, and he got no sound whatsoever when he went off the straight line mode. So the moving coil has several different impedance matching features in it. You can push the switch in and it gives you 33 ohms rather than 100 ohms. You also have 100 puff, 200 puff, 300 puff, or 400 puff loading that you can use to optimize your moving coil load, and this switch right here tells you you're in moving coil or moving magnet mode. So right now it's in moving coil mode, and off it's in moving magnet mode. Right here is our loudness switch, so the LED comes on, and our subsonic filter, and it comes on here. And so that is basically a tour of the front controls of this unit. I should also mention that there is a jack for you to plug your headphones into. So before we get into the back panel, I wanted to let you know that I researched the subsonic indicator, and what happens is that if the A-9 detects a rumble, like say playing a record that is really low in frequency, it will turn that indicator on, which is a cue for you to maybe switch in the subsonic filter if you want. So that's all that it does. That's kind of neat. I didn't want any of you to lose any sleep as to what that may have done. That being said, let's start over here, and we have a pair of gold-plated RCA jacks for your phonograph. We have a nice grounding lug situation going on there, which makes it easy to get your turntable's grounding wire hooked up. We have your tuner inputs here, your auxiliary inputs here. Here's your tape 1 inputs and your tape 2 inputs. And we have 2 sets of speaker inputs. They are not banana jack friendly, unfortunately. We also have 2 switched AC outlets and 1 unswitched AC outlet. It doesn't have any pre-out main in jacks, which is kind of a bummer, but that's just... So here we have the inside top view of the Pioneer A-9 integrated amplifier. Right here is our power transformer, a nice good sized toroidal type power transformer. Right behind it is one of the power supply boards, this guy here, and there is another power supply board right down here. Underneath this canned area are the 2 big filter capacitors. These are obviously our heat sinks for the left and right channels. Right here we have more control boards for the front controls. This pot and this pot adjust the accuracy of the power meter LED display. Over here we have your bass and treble controls down here. Those are the pots for those. You can see a different kind of view of the unit from this side as well. Down here you can kind of just make that out there, that little box, that is the volume control potentiometer assembly, and that's a sealed device. So this board right here is called the equalizer amp assembly, and the culprit, the one resistor R104 that went bad, was that little guy right there. So this is the underside of the A-9 integrated amplifier. You can see that the output transistors mount to the heat sinks here and here, 4 transistors for each channel. They're nicely wired to the main filter capacitors, which are underneath this metal shield. And you can see part of the board under here for the driver and the speaker board, and that's where the speaker relays mount. So this kind of just gives you an overall feel of how difficult this unit is to work on, at least in my opinion. It's a nightmare. So the A-9 was brought to me with a problem that it would only play music when it was in the line straight position. In other words, it was bypassing the tone controls, the bass and treble controls. Here's a block diagram of the A-9 from its service manual, and you can see that it gets switched for either the line straight or to the tone control through this little relay here. And the normal position for it is just to go straight through, and it goes right into the power amp. If you select the tone portion of the switch, then it goes into the tone control stuff where you can set the bass and treble and everything. So in troubleshooting, I measured the signals coming in and out of the relay in either the line straight position or the bypass position, and I was getting signals out the way that they should. So it was apparently dying somewhere in the tone control portion. So here's the schematic of the tone control portion, and after a little bit of measuring voltages, what I found was the voltage right here, this minus 15 volts coming out of the equalizer amp assembly here that goes over to the tone control. That minus 15 volts, if you follow it, supplies the minus 15 volts needed for these 2 op amps. There's 2 dual op amps. So those things are not going to come on with just 15 volts supplied. So tracking down why it wasn't getting any voltage there, it turns out this little resistor, this 1.3 k ohm R104, was opened up. I really don't know why it opened. I replaced it and slowly measured the voltage as I was cranking up the power to the whole A9 using a variac and slowly watching the voltage here, and it seemed fine, and I never found anything wrong in this part of the circuit that would be causing too much of a draw on it. So it just must have been a resistor that got aged out for some strange reason. Anyway, so I replaced that and everything worked fine, other than I needed to clean and lube the bass and treble controls. The first piece of data we have for the A9 is the THD SNR plot at 1 kilohertz, where the amplifier is set to give 29 dB gain and produce 5 watts of output into 8 ohms. As you can tell, the right channel has about a 4 dB worse SNR, and its THD is not nearly as good as the right channel, but it's still decent. So here we have the same plot as the previous one, with the exception that the tone control was taken out of the line straight mode and put into the mode where the signal goes through the tone controls, which were set flat. So we still have a 1 kilohertz signal with the gain set for 29 dB and an output power of 5 watts into 8 ohms. But as you can tell, the channels are very well balanced as far as THD percent and SNR, and even the THD plus noise. So based on that, you would never want to take this out of the tone control mode. Here we have the frequency response with the A9 operating at 5 watts into 8 ohms output with 29 dB of gain, and I am using the auxiliary input, which I have been using for all the data so far. Now, there really isn't a spec at the output of the A9 into a load. There is a frequency response using the tape monitor output, but I have not done that. This is actually at the load, and it actually looks pretty good. If you just look at the yellow left channel, it looks to be maybe 0.6 of a dB, I would say, at 20 kilohertz. So that's pretty good. That's a pretty good response, and the right channel is similar. The little peaking that you see there is some of the 60 hertz hum from the power supply sneaking in. So here we have the frequency response under the same conditions as the previous frequency response, except for we are in the tone mode. So the line straight mode is off and we're going through the tone controls, which are set flat, and you can tell there is a low frequency roll off that we didn't have before, below about 100 hertz or so, and the high end looks to be about the same. Here is the THD SNR plot at 1 kilohertz for the moving magnet phono input, and I really couldn't find much of a spec for it other than a greater than 90 dB SNR at 1 kilohertz, which we are nowhere near as meeting. However, 66, 68 dB SNR is not bad, and the THD is fairly low, so I would be happy with this response. Here is the frequency response of the moving magnet phono stage, and I should point out that this piece of data and the one previously were measured at the tape monitor output for tape 1. There is a spec on it, and it's plus or minus 0.2 dB from 20 hertz to 20 kilohertz, so we're actually meeting that. There's a little bit of noise there from the 60 hertz line coming in, but overall this is very encouraging. So here we have the THD SNR plot at 1 kilohertz for the moving coil phono stage measured at the tape monitor 1 output. The THD is not so bad, but the SNR and the THD plus noise is definitely a lot worse than the moving magnet phono input stage. And that's probably because with such a low level, the 60 hertz noise is getting in. And if this were a unit where you wanted the moving coil stage to work better, you would probably go through and replace a lot of the capacitors in the power supply section. So here we have the frequency response of the moving coil phono stage measured at the tape monitor 1 output, and it basically is meeting the requirements of plus or minus 0.2 dB. However, that's only if you disregard the noise, particularly the one at 60 hertz, which comes and goes, as well as the little spikes you're seeing in the red channel. There does appear to be a problem with the right channel when the moving coil stage is used, and if this is left on longer, the noise level really increases in it. That doesn't happen with the moving magnet stage at all with this, but the moving coil stage has some issues, and the owner of this unit doesn't really care to use the moving coil stage, so it's not something I would investigate further. So here we have the THD SNR plot at 1 kilohertz for the condition where the line straight mode is selected, so we're bypassing the tone controls. And we do have the signal into the auxiliary input. The power has been adjusted to get the rated maximum of 110 watts, well, 108 watts for the left, 111 watts for the right, into 8 ohms. And as you can tell, they're a little bit different SNR-wise. The right channel is about 6 dB better than the left channel. And you can see the noise level of the left channel seems to be a bit higher. Also, the THD for the left channel is a little bit better than the THD for the right channel. THD plus noise is about 60 dB for both, so that's not great, but we are at a very large output signal. Now the spec for this amplifier is for a 0.003% THD at 110 watts per channel into 8 ohms. So we are not quite at the 0.003% THD spec requirement from 40 years ago, but nobody's going to hear 0.005 or 0.0085% THD. So here we also have the THD SNR plot at 1 kilohertz for the auxiliary input driven into an 8 ohm load. The difference is this time we have the tone control mode selected, so the line straight mode is off and we're going through the tone controls and they are set flat. Now when we did this at the 5 watt power output, it looked pretty good, but this time it doesn't look as good as the line straight mode did with this amount of power. So this last piece of data shows the THD SNR at 1 kilohertz once again, with the tone controls being used but flat. So we are not in the line straight mode. And for some reason, this looks much better when I bump the power up to get between 130 watts in 8 ohms and 134 watts into 8 ohms. I don't really know how to explain it other than the noise must not have gone up at all and the signal level increased, so the difference improved between the two. And as you can tell, the THD and the SNR are decent. This amp probably could get cooking a little bit more than 130 watts, but I decided just to stop here. I listened to the A-9 for about 30 minutes using a variety of music, and I did kick up the levels so I was reaching SPLs between 84 and 92 dB. Now the power meter was reading 30 watts to in between 30 and 110. I'm not sure exactly what that is according to the scale, but I would sometimes hit peaks in there and everything seemed fine. I do prefer using the mode where the tone controls are switched in so I can tweak the bass and treble just a little bit, and it seemed to do just fine. I really enjoyed using the amplifier. Now one of the things I noticed was it does get hot. The top of the unit I measured 152 degrees F at some points at the end of the testing, which is on the higher side of things that I measured. So I would advise, if you buy one of these, that you definitely keep it in a well ventilated area, preferably on the top shelf of wherever it is that you're going to end up using it at. Other than that, I think it's got a lot of nice features on it for an amplifier. Also, the other caveat on it is this is a real booger to work on, and for most things, it just would probably be very expensive to repair, just because the way it is to get at it, and it would not be something that I would really want to do much with other than the bit I did, and that was enough of a pain. I forgot to mention that I did clean and lube the bass and treble controls while I had it open, and the volume control is a sealed unit, so there's not really much you can do with it, and it seemed pretty noise free, but these did get a little extra love to them. So that being said, it's a nice unit if you could pick it up for the right price, and it does work. Once again, I thank you for watching, and if you have not subscribed, please do so, and of course I would like to hear any comments you have, and have a great day or night.